Hello, and welcome back to Teacher Gimble's channel. Today we'll be going over Illustrative Math, Algebra 1, Unit 2. If you like this video, please make sure to like and subscribe by hitting the button that's right over here. Also, if you haven't seen, I just launched a Patreon page. So if you like my videos and you want custom videos of any content, if you subscribe to my Patreon page, I will create those videos for you. All right, you can find the link in my bio. Let's get started. Problem number 1. Priya is buying raisins and almonds to make trail mix. Almonds cost $5.20 per pound, and raisins cost $2.75 per pound. Priya spent $11.70 buying almonds and raisins. The relationship between pounds and almonds and pounds of raisins are, and the total cost is represented by the equation 520 times A, which is the number of almonds, plus 275 times R, which is the number of raisins, is equal to 1170. How many pounds of raisins did Priya buy if she bought the following amount of almonds? So in this case, we're going to say if A is equal to 2 pounds, and we want to know how many raisins. So we know what A is equal to. So for 1, we're going to say 5.20 times 2, because we know our A, which is the number of almonds she brought, times the number of raisins, which we don't know, is equal to 1170. So we're going to solve this equation, which is 520 times 2, which is 1040, plus 275 times the number of raisins is equal to 1170. And we're going to do this multiple times for this question. So keep track of how we're solving it. We end up with 275 raisins is going to equal $1.30. Now we divide both sides by 275, that's 225, to get our R isolated. And R, remember, represents the amount of raisins. And we pull out our handy-dandy calculator, which you should have on the side for this whole lesson, because we'll be doing a lot of computations in this lesson. So when we're doing mathematics, and especially algebra, we want to make sure that we're working smart and not hard. So we don't want to be spending all of our time doing computations, because we're just trying to figure out the answer. And that gives us 0.43. I rounded to the nearest 100th. And so R, in this case, she got 0.43 pounds of raisins. Now, if almonds is equal to 1.06, we're going to go ahead, and I'm going to do the equation over here. And we're going to say we know it's 520 times the amount of almonds she got, which is 1.06, plus 275R is equal to 1170. So we're going to go ahead, and we're going to use our handy-dandy calculator. And we're going to say 520 times 0.06 is equal to 5.512 plus 275R is equal to 1170. And I'm going to subtract from both sides. And we end up with 275R is equal to 1170 minus 5.512, which is equal to 6.188. And we have to divide both sides by 275 in order to come up with the final amount of raisins that she brought. So raisins in this case is going to equal 2.25 pounds of raisins. Now, this is a lot of work, so we're actually going to make this process a little bit easier. So pause this video if you want to go back over this work. So the next one says A is equal to 0.64 pounds of almonds. So I'm going to write my equation, which I've been doing over and over again. And each time I have to solve it, it's actually a lot of work. So I'm going to save a little bit of time here. Sorry, I forgot my variables. And I'm going to say, I want to know how many raisins. So I'm going to actually subtract the almonds from both sides, which tells me 275R is going to equal 1170 minus 520 times A. I also know that I want to know how many raisins in general, so I'm just going to divide both sides by 275. What this tells me, and let me move my face out of the way, is raisins is always going to equal 1170 minus 520 almonds divided by 275. And the reason this is helpful is now when I'm solving number 3, rather than solving a whole equation, I can just go ahead and I can plug in my A. And this whole equation or expression can then go into my handy dandy calculator rather than solving it. Now I know it took a minute to find this expression in the first place, but if we had done this for the first question, we would have saved a whole lot of time in calculation and solving equations. So I always like to solve for the variable first, which gets us 3.04 pounds of raisins. And if she brought 8 pounds of almonds, well, we just calculated it. Her raisins will equal exactly this expression. So when you solve for R, it's going to tell us whatever A plugs in, that will get us the amount of raisins that she bought. And this is a super useful skill that you'll see over and over again in this content area, but also in physics and in any type of science that you do, and in future math areas as well. So this is a useful skill to continue working on. Problem number 2. Here is a linear equation in 2 variables. 2x plus 4y minus 31 equals 123. Solve the equation first for x and then for y. So we're going to first solve for x, which means we want to isolate x. We want to get him alone. So first let's get rid of my 4y, and I'm going to get rid of my 31. And I can do that in just one step. So these cross out and these cross out. My 2x doesn't go anywhere. Now I know that I can combine my 123 and my 31. 123 plus 31 is 154, and I can do that because they're like terms. And this 4y cannot be combined with anything, so he comes down as 4y. Finally, I have to divide by 2. And if I divide this by 2, I divide this guy by 2, and I divide this guy by 2. Every single term gets divided by 2, which gets me x is equal to 154 divided by 2 is going to be 77 minus 2y. And we are done. Now, if we wanted to solve for y, let's go ahead and do this in pink. We are going to start with writing our equation. We're going to write it small over here where we have space, plus 4y minus 31 equals 123. We want to get y alone, so I'm going to get rid of my 2x. I'm going to get rid of my 31 like I just did before, but if I did it on the left side, I have to do it also on the right side. I know my 31 can combine with the 123 because I saw that from the last question. I'm not adding, I'm subtracting my 2x. This crosses out, I'm left with 4y is equal to 154 minus 2x. I need to get my y alone, so I divide by 4, which means I divide him by 4, I divide him by 4. My y is now isolated. 154 divided by 4. I could go ahead and do that in my head or plug it into my handy dandy calculator, which gets me 38.5 minus 1/2 or 0.5x. And I am done. So in the first part, we solve for x, and the second part, we solve for y. And that's what it means. When we say solve for x, it means just figure out what is x equal to when x is isolated. When we solve for y, figure out what y is equal to when y is isolated. All right, let's go on to the next question. And I really like these questions because there's things that are useful and things that aren't, and this is actually particularly useful. A chef bought 1701 worth of ribs and chickens. Rib cost $1.89 per pound and chicken cost 90 cents per pound. The equations 0.9 times C, the amount of chicken, plus 1.89 times R, the amount of ribs, is equal to 1701, represents the relationship between quantities in this situation. Show that each of the following equations is equivalent to 0.90C plus 189R is equal to 17.01. Then explain when it might be helpful to write the equations in this form. So, looking at my equations, I see in the first one they solve for C, and in the second one they solve for R. So I'm just going to go ahead and I'm going to check that they did it correctly. So I'm going to write down my original equation. So this is how much they spent. They spent 1701. It was 90 cents per chicken, 189 per rib. I forgot my variable, but that's okay. And I'm going to solve for C by first subtracting 189R on both sides. And I get 0.9C is equal to 17.01 minus 1.89R. I cannot combine my variables because there's an R term here and there's no R over there. To isolate the C, I'm going to divide every single term by 0.9, which gets me the C living alone. In my handy dandy calculator, I say 17.01, 17.01, and I divide it by 0.9, and I get 18.9, and I say 1.89 divided by 0.9 gets me 1.89. I typed that in wrong, which is okay. We all make mistakes. Divided by 0.9, that gets me 2.1. And my R doesn't go anywhere. So this right here matches this equation. So we are good to go. So we showed that it is equivalent. Now, when would it be useful? Well, C represents the amount of chicken. So dependent on R, so say I bought 5 pounds of ribs, I would just plug in 5 for R, and it would tell me immediately how much chicken I had bought. So I bought 2 pounds of ribs. When I plug in 2, I would see how much chicken I could buy using that same budget. Now let's double check the second one. So we're going to start with the same equation. 0.9C plus 1.89R is equal to 1701. We want to isolate the R, so we're going to subtract the C term from both sides, which gets us 1.89R is equal to 17.01 minus 0.9C. Now to get the R alone, we are going to divide each term by 1.89. So the R by itself, and I pull out my handy dandy calculator one more time, I divide it, and in this case, since I'm using a calculator, I get 9, and then I get 1.09 divided by 1.89, and I get 0.48C, which is not what this term says. But I'll tell you a trick with a calculator. I see that this term is 0.48C. I'm going to double check that when I put this into a calculator, 10 divided by 21, it's also 0.48. So I can see that my calculations are correct. The only difference here is this is 9 minus 0.48. This is negative 0.48C, which is this whole term right here, plus 9, which is this term right here. So even though we flip the terms, it is still equivalent expressions. Now in this case, this tells us, say we brought 2 pounds of chicken, it tells us how much of our budget is left over to buy ribs, or how many ribs we can buy, given that our budget is 1701. So this tells us if we bought 5 pounds of chicken, then how many ribs we bought, keeping within exactly our budget of 1701. So this allows us to figure out the amount of ribs. And again, this is a useful skill that is super valuable for any type of math content you'll be going over in the future. Problem number 4. A car traveled 180 miles at a constant rate. Complete the table to show the rate at which a car was traveling if it completed the same distance in each number of hours. So we know that it traveled 225, and we know that it traveled 180 miles. So we want to complete the rate at which the car was traveling if it completed the same number. So over 5 hours, hold on a second. I need to read this question a little bit more carefully, which is important sometimes to reread a question. All right. So in this question, it is saying if he traveled 180 in 5 hours, if he traveled 180 in 4 hours, if he traveled 180 miles in 3 hours, or 180 miles in 2.25 hours, what is the rate for each one? Now, if you remember, distance is equal, or not, rate is equal to distance divided by time. So in this case, the distance he went was 180. It took him 5 hours to do it, which means he went at 36 miles per hour. For this one, well, he still went 180 miles because in every single one of these, he went 180 miles. And we have distance is equal to, it took him 4.5 hours, which makes him go at 40 miles per hour, or the car. It's not a he. 180 in this case divided by 3 means he went 60 miles per hour. In this last one, he went 180 miles in 2 hours and 25 minutes, which is him going pretty fast, and that gave us 80 miles per hour. Now, For number 2, it asks us to write an equation that would make it easy to find the rate at which the car was traveling in miles per hour if it traveled for t hours. So we know rate is equal to distance over time. And in this case, our distance has never changed. Our distance is always 180. So it's 180 divided by t, because this is our rate given our time. So rate is equal to 180 divided by t. All right, let's go on to the next question. Problem number 5. Bananas cost 50 cents each, and apples cost $1 each. So I think at Trader Joe's, bananas cost 19 cents, so 50 cents is expensive. Select all the combinations of bananas and apples that Elena could buy for exactly $3.50. 2 bananas plus 2 apples. And I'm going to say A is bananas, A is apples, B is bananas. So if bananas are 50 cents, it would be 2 times 50 cents plus 2 times $1. 2 times 50 is 1, plus $2 would be 3. It says exactly $3.50, so even though she could buy 2 apples and 2 bananas, that's not exactly $3.50, so we're going to cross it out. 3 bananas and 2 apples would be 3b, but 3 times 50 cents plus 2 times 1, which gets us $1.50, plus $2, which is $3.50. Cross that out. And that is correct. So B is a correct answer. C would be 1 banana, so it's 1 times 50 cents, plus 2 apples, which gets us 50 cents plus 2, which is $2.50. That is not exactly $3.50, so we cross them out. 1 banana and 3 apples would be 1 times 50 cents, plus 3 times $1, which gets us $3.50. So he's good. 5 bananas and 2 apples, so 5 bananas, 5 times 50 cents, plus 2 apples, which is going to get us $2.50, plus $2, which is equal to $4.50. She cannot buy that. But 5 bananas and 1 apple, well, 5 times 50 cents, which is $2.50, plus, well, 1 apple is just 1. Ooh, I did this backwards. Do you see how it's 2 apples, 2 apples? So I put the 2 first. The 2 should not, it's $1. It's 1 times the number of apples. So in this case, it would be 1 times 2, 1 times 2, 1 times 3, 1 times 2, because it's $1 per apple, so it's 1 times 1, which is equal to $3.50. So I did all of the above questions correctly, but my equation is 2 bananas. This equation is not correct. And again, we consistently make mistakes in mathematics, and I do too. So rather than editing this out and redoing it correctly, sometimes I like to go and just go over what I did. So it's 50 cents per banana. So it's 50 cents per banana plus $1 per apple. So although all of these are the correct equations we would use to solve this, I would like to see the actual equation written like this, where B is 3. So 3 bananas times 50 cents plus 1 apple, $1 per apple for 2 apples. And so B and F are the correct answers, but our equation, the variable tends to go second and is in parentheses. So that is how I would rewrite it to have it rewritten correctly. All right, let's go on to the next question. And put a question in the comment if you have any issues about what I did, and I can help explain it more. A group of 280 elementary school students and 40 adults are going on a field trip. They are planning to use 2 different types of buses to get to the destination. The first type of bus holds 50 people, and the second type of bus holds 56 people. Andre says that 3 of the first bus and 3 of the second type of bus will hold all the students and adults going on the field trip. Is Andre correct? Explain your reasoning. Well, if he had 3 of the first type of bus, that would be 50 times 3 people. It would have 150 people. Plus 3 of the second type of bus would be 56 times 3, which is 168. And we'd have to add these both together, which gets us 150 plus 168. And you can do this in your head or using your handy dandy calculator, which gets us 380 seats total. Now there are 280 elementary school students and 40 adults. So the total number of people who are going on the trip is 280 plus 40, which gets us 320 people. So if there are 318 seats and 320 people going on the field trip, Andre is not correct. You would need more buses. All right, let's go on to the next question. Elena says that the equations A and B are not equivalent. Write a convincing explanation as to why this is true. Well, I'm going to rewrite my equations over here because I like to see them with some space. 13 minus 5x is equal to 48. And here we have 5x is equal to 35. Well, these two are difficult to compare, so let's isolate the x and go ahead and see. So if we have 5x is equal to 35, that means x has to equal to 7. In this case, with this equation, I would start by subtracting 13 from both sides. I would get negative 5x is equal to 35. And then I would divide both sides by negative 5, and I get x is equal to negative 7. So for the first equation, equation A, x is equal to negative 7. And the second equation, x is equal to 7. And so because the answers that we need to plug in for x are different, it means that the equations are not equivalent. And that's the easiest way to figure out if these guys are equivalent. So Elena is wrong. Pause if you need to take a second to write that down. Problem 8. I gotta zoom out. We have, to grow properly, each tomato plant needs 1.5 feet of soil, and each broccoli plant needs 2.25 square feet of soil. The graph shows the different combinations of broccoli and tomato plants in an 18-foot plot of soil. Match each point to the statement that describes it. The soil is fully used when 6 tomato plants and 4 broccoli plants are planted. Well, the soil is fully used any point on this line, because this line represents the 18 square foot pot of soil being fully used. 6 tomato plants is here, 4 tomato plants is over there, so that is point C. Cross it out. Only broccoli was planted, but the plot is fully used and all plants can grow properly. So I know I'm looking at this line, and over here, I see we have 8 broccoli plants, no tomato plants, so that would be point A. Let's cross it out. After 3 tomato plants and 2 broccoli plants were planted, there's still extra space in the plot. So over here, this represents where less than the full amount of soil is used, and to the right, it represents where more of the soil was used. So here we have 3 tomato plants, 2 broccoli plants, and less than the full amount of soil. This is equal to B. Cross it out. Finally, with 4 tomato plants and 6 broccoli plants planted, the plot is overcrowded. So over here, because we're above the line, we have used too much soil, and we have planted 4 tomato plants and 6 broccoli plants. And this is equal to D. All right, let's go on to the next question. And problem 9. This just keeps going. Select all equations that are equivalent to 3x minus 4 is equal to 5. So we need to figure out what x is equal to. That's what I like to do first. So 3x is equal to 9, divided by 3, x is equal to 3. And let's go ahead and zoom in so we have a little bit more space. Oh, can't do it right now. That's okay. So here we're going to divide by 3. We're going to divide by 3. X is equal to 3. Our answers match. They're equivalent. Negative 4 plus 4 goes away. So this gets us 3x is equal to 9. They match. We're equivalent. We add 4 to both sides, which gets us x is equal to 6. Nope. X is not equal to 9. He's equal to 3. And this guy, let's subtract 5 from both sides, which gets us negative 9 is equal to negative 3x. Divide by negative 3 on both sides, which gets us x is equal to 3. This guy's correct. And we're done. Let's go on to the next question. Problem number 10. Hand is solving an equation. We solved a lot of equations today. He took steps that are acceptable, but ended up with equations that are clearly not true. What can Hand conclude as a result of these acceptable steps? So let's go over and look what he did first. Original equation. Here, he used the commutative property of addition and just put the 2x to the left and the plus 5 to the right. Here, he added 7x plus 2x, or 7x minus 2x, which got him 5x, which is good. And here he he subtracted 5x from both sides, which left us with 6 is equal to 5. So something is wrong. A, there is no value of x that can make the equation 5x plus 6 is equal to 7 plus 5 minus 2x true. B, any value of x can make the equation true. C, x equals 6 is a solution to this equation. D, x equals 5 is a solution to this equation. Well, the two answers we can cross out immediately is we can't conclude from his work that either of these are a solution. Now, in this case, say, let's plug in 0 for x, for b. So it would be 5 times 0 plus 6 is equal to 7 times 0 plus 5 minus 2 times 0. This gets us 6 is equal to 5 minus, well, if this goes away is equal to 5. Also gets us the wrong answer. So it's clear that any value of x can't make the equation true, which leads us to assume that there are no values of x that make this equation true. All right, so we found our correct answer. If you like this video, please make sure to like and subscribe. If you like this video and you want personalized videos, head over to my Patreon page and subscribe, and I'll create your own videos over there. I'm looking forward to seeing you next time.